So now we carry on with the Africa webinar. It is our first edition with the Africa webinar, with the purpose of showing the solutions that we have in South America and that can be provided to other countries, emphasizing here in this case the African countries. As we have translation into English, so other countries are also attending. Welcome and thank you. So we're going to have Brentag's presentation with the topic Compatibilizing agents for polypropylene compounds. It's a Brentag's presentation. We have Rafael Bringo speaking to us here today, so he's here with us today. Hello, Simone. Good morning. How are you? I'm fine, and you? Great. So we are running a little bit late, but we are not shortening the presentations. We want you to address, full content of your presentation. So I apologize for any kind of minor delays, but I wish you an excellent presentation. You may go ahead. Thank you, Simone. Can you see my presentation? Yes, we can see the presentation. All right. Very well, perfect, thank you. Market. But Brentag Chemistry is a chemical distribution company. We operate in more than 77 countries. So our supply capability is very high. We work with different kinds of materials. So today we're going to be talking about polymeric materials. We are going to talk about solutions on additives to make, polypropylene, which is known as a commodity, right? And to make polypropylene then a material that has, better mechanical properties, so that the polypropylene can really live up to the level of the engineering plastics. My name is Rafael Rangel. I am a technical expert at Brentag Chemistry, working with the plastic foil and rubber market. So beginning with my presentation will be organized as such. I'm going to make a brief introduction on the additives, and then we are going to cover the compatibilizing agents, and then I'm going to explain to you how these materials, they act, their mechanisms of action. And then we'll introduce our solutions in terms of compatibilizing agents. And then finally, I'm going to address the key market applications. And then we're going to open for questions, okay? First, before speaking about any kind of additive, it's highly relevant to survey the importance of the additives. It's very much important to discuss the functions of the additives, right? So first, the additives, they help in the processing. And in order to support the processing of polymeric materials, we have several kinds of additives that can be used. The antioxidant ones, for example, so they will kind of promote thermal stability for the production of different kinds of materials in different process conditions. Another example that I may give to you is cost reduction. Rubbers, foams, they really can reduce the cost by, using additives or by using fillers. Well, the reinforcement filler should have a very good interaction level with the polymeric matrix, so much so that the fillers do not interfere, interfere that much. They should not, for example, cause a significant reduction on the mechanical properties of our materials. So we should be attentive to that as well. And then finally, the modification of properties, which is what we are discussing here today, right? So we have polypropylene, which is widely known as a commodity, and the mechanical properties of the polypropylene are regular properties. And then we are able to further improve the properties by adding additives. So we add, for example, reinforcement reinforcement agents, we can use fibers, or we can use mineral fillers, and then we are able to enhance the potential benefits by adding this reinforcement agent. So we use the compatibilizing agents to do that as well. So the role of the additives is, mainly enabling a wide array of applications for the materials. So by using additives, you are able to use a certain material. This material, for example, would have certain characteristics. By using additives, you make this material, something applicable to so many end applications. So that's the role of the additives. The additives, they have to, fulfill some requirements. The additives must be efficient in terms of their function. What is the function of an additive? Let us say that there are two different kinds of compatibilizing agents. Let us say that we have compatibilizing agent A, and in this case, we need to have a high dose of the component, 3% of the weight of the product, for example. And we have compatibilizing agent B. In this case, just at 2%, you are able to obtain the very same function and promote the very same benefits. So compatibilizing B agent at a lower dose is more efficient, right? It must be stable throughout the process. For example, if we work with the compatibilization of polypropylene and glass fiber, the process temperature can be very high, close to 270, 280 degrees, or even more than that. Right? So we could not use this compatibilizing agent made of a polymeric matrix of polyethylene. And why is that? Because the polyethylene may be early degraded. So there might be a prior degradation. Because, polyethylene doesn't have the same thermostability characteristics as the other element, the polypropylene element. The material must have a good dispersion and distribution rate. So we believe that a polypropylene compound used with a talc that is widely used in the automotive industry. So talc should be, distributed throughout the part. And in order to make the additive effective, the additive should be well dispersed, well distributed as well. So that's one of the challenges when it comes to additives. So the additives should not migrate. If it migrates, it has to be controlled. So when we talk about a UV stabilizer, migration must happen because it really acts on the surface. So we have to displace it to the surface. Totally different from flame retardant additive.
If the anti-flame agent migrates to the surface, there is a negative impact, which is the creation of a white pellicule in the surface of the polymer, which is not good for parts, for foams, or other rubbers, because there will be this white layer on the surface. There's a way to control this migration, which we do not desire in a non-flammable material, which is by using a compatibilizing agent. Finally, this should not have an impact in the properties of the material. We know it's common to use filler loads to reduce costs in compounds or composites. However, it is also necessary to use a compatibilizing agent because you can lower costs by using the fillers, these mineral fillers. Through the use of the compatibilizing agent, one is capable of improving the features of the polypropylene composite. So now looking at compatibilizing agents. What is the role of compatibilizing agents? I spoke briefly about this. It's important to understand that these agents, they represent a bridge. You have a polypropylene, which is apolar, and you have a reinforcement agent or a mineral load, an anti-flame compound, and these are highly polar materials. That has an impact in the production of the polymer. The impact is that there is no interaction between these two different phases. These materials, they don't connect between each other. So a way of being successful in using these agents who are foreign to polypropylene is precisely the use of a compatibilizing agent, which then becomes a bridge, so that these two different stages, polar and apolar, can have a connection. In this slide, you see an example of production of a polypropylene with a graft, with maleic anhydride. So there is a graft performed here. We have the polymer matrix, which is the polypropylene. Here we see the structure of the polypropylene. We add peroxide to the formulation. The peroxide then breaks the polypropylene chain, and in this point here, there is a free radical which will bind to the maleic anhydride molecule. So what is the crux here with the matter of this molecule? The molecule has an apolar phase in its structure, only with carbon and hydrogen. And we see this highly polar phase here, as you see here with the laser pointer, due to the oxygen that is part of its very structure. So here we do the following. We have a polypropylene that was modified in its structure, and it goes from an apolar to a polar material, as we can see in this example right here. So let's suppose that down here we have the polypropylene chain. We have this group here, which is the maleic anhydride, and we have this mineral load, which can be the reinforcement agent, which is also polar. This is interesting. We are capable of causing this binding, a connection between the two different phases. So one actually couples to the other. The mineral load, or the fiber, for instance, is coupled in a very powerful way. What is the benefit of that? Well, here you see some studies from universities that have worked with our products. On the left-hand side, in image A, you have a polypropylene composite with a bamboo fiber. Here we can see that the fiber is kind of loose from the polymer matrix. There is no binding between the matrix and the fiber. Well, what is the impact of that? Precisely these gaps, these voids you see here in the image. And they happen, these voids happen, because the fiber is removed. This microscopic image, or this microscopic analysis, was conducted after a traction assay in a polypropylene with bamboo fiber. And that was the impact without using the compatibilizing agent. Just look at the right-hand side now. When we use this agent, the impact is completely different. You can see that the fibers here are wet, quote unquote, as we call it. This is the term that we use for this type of change in the structure. So this wet stage implies on a better binding between the polypropylene and the bamboo fiber. So we can increase the mechanical properties of the material. So if we had resistance to traction or resistance to, or a strength to the material, we now potentialize or improve these properties through the use of the compatibilizing agent. Here we see another interesting example, which is very much applied in the market. It is the use of glass fibers in a polypropylene composite. This is a polypropylene resin. Here in images A and C, we have the material without the agent. We can see that the fibers are removed. We see the holes right here, the voids, the empty spaces. This shows that in the tensile strength, when we analyze the tensile strength, these fibers have been removed. This image C is very interesting. This is the fiber without the compatibilizing agent, and it looks loose in the polymer. We don't see an interesting interaction between the materials. And there isn't an interaction indeed. Well, let's just see what happens when we do use the compatibilizing agent. That's what we see on image B. We don't have the same density of void spaces in the structure of the composite. And right here on image D, which is an excellent image, it shows precisely what we were speaking about before, which is the wet, quote-unquote, polypropylene in the glass fiber. As this is wet, you increase the interaction between the polypropylene matrix and the disperse phase, which is the glass fiber. So we increase this connection, so the mechanical strength is then transferred from the polypropylene matrix to the glass fiber. And of course, the glass fiber has more mechanical strength. As a consequence, we empower the mechanical properties of the composite. Many companies currently use polypropylene with glass fibers, bamboo fibers, with wood, dust, or mineral loads without the use of compatibilizing agents, maybe because of a lack of knowledge, maybe because of a lack of analysis. But the mechanic properties are very much improved through the use of these agents. Here you see the line that Brandtech has available of these agents. It's a full line designed on the interaction between polypropylene and the mineral filler, or the mineral load, or glass fiber. So we have these agents right here, which also play an important role in promoting the interaction between different polymer materials. So nylon, which is polyamide, for instance, and polypropylene, which allows us to create this interaction or binding between two different types of materials. Another interesting use is precisely for composites with flame retardants. In free halogen flame retardants, we have a large use of anti-flame materials. It can reach 50%, and this has an impact in the reduction of the mechanical properties of the material. The compatibilizing agent then acts as to improve the interaction between these two materials, therefore improving its properties. In our line of products, we also have agents for high-density polyethylene, linear polyethylene, impact modifiers, and impact modifiers for styrene materials, polycarbonate, PBT, sun ABS, and others as well. Now focusing on the compatibilizing agents themselves and the sheet for the materials, we have different functionalities focused on two different principles. So we have acrylic acid based and also maleic anhydride in different functional levels or dosing levels, and also with different rheologies. So one could say, well, Rafael, I need a material for extrusion purposes. Well, in that case, we need an agent of low fluidity levels, because this will help in the process. Or maybe someone could need a material for high levels of fluidity for injection processes, for instance, which require to fill a mold or a cavity. In these cases, we have different types of materials with different features. Speaking specifically about acrylic acid, the main appeal of this type of agent is to create an interaction between plastic polymers and the metallic parts. So if you need material for the adhesion of a plastic film or a plastic part into a metal part, well, through this material that has this grafted material, you can create this connection. Our provider for this line of materials is SI Group, as I had mentioned. Brandtag Química distributes chemical products, and in this case specifically, our partner is the SI Group, with a full line of antioxidants for all different purposes and applications. We also have stabilizing agents, UV absorbers, also for the whole polymer market. And here we are speaking about plastics, rubbers, and foams. We also have the Polybond line. These are the compatibilizing agents we've just mentioned. We have for polyolefins, which are polypropylene and polyethylene, and we have the line of impact modifiers. What are the main uses and applications of these agents? Well, these agents are very much used in the auto industry. The auto industry is constantly using composites with these reinforcement agents, such as glass fiber. And in order to empower these composites, they use compatibilizing agents. Another example is using it when there is a metallic paint process. Polypropylene has to go through a couple of processes, such as what we call the crowning process. It's like a shock of electrons in the surface so that the paint adheres to the part. And with the compatibilizing agent, you don't need these processes anymore, because it changes the polarity of the polypropylene to create this better interaction with the paint, with the metallic paint. Other interesting applications in the electric wires market because they use a high amount of flame retardants. And of course, the mechanical property is decreased by the flame retardants. And if one wants to mitigate or reduce this negative effect, you can use these agents. Same thing goes for wood dust or wood plastic composites. And the use of compatibilizing agents is very much needed in these applications. And we have to use the right compatibilizing agent because we have different levels, which is quite interesting. And also we have the blends, the polyethylene blends, polypropylene and nylon, polyamide blends that create a whole new spectrum of applications. I would like now to share the information. Once again, our partner for this line is the SI Group, but we also work with LA Queiroz for PVC. We work with Dow for our foam line. We have a full portfolio of foam products. We have the Kraton line, in which we work with SBS modifiers. We are working quite strongly with the circular line, and in this afternoon I'm going to speak more about this. Tronox is titanium dioxide for white coloring, and the TOSA line, which is a synergy agent for flame retardants. Quite an interesting material that plays the role of suppressing smoke, reducing the dosage of anti-flame agents, and it also increases the mechanical properties of the material because in itself it is a reinforcing agent. So it's a very special and interesting material that we offer in this market. Well, that's what I have for today. I hope that I was able to be clear in my explanation about the compatibilizing agents market. You see my contact information on the screen. If you have any questions, any requests, please feel free to contact me through email, WhatsApp, or phone call. I'm available for any needs you might have. Hello, Rafael. Thank you very much for your presentation. Such a full and interesting presentation. We have a couple of questions for you. You mentioned the loss of mechanical properties for wires and cables and the use of these agents in this case. What is the gain of electromechanic properties? What is the gain? What is the positive impact when you use a compatibilizing agent? Well, in the wire and cables market, since we work with safety in civil construction projects, it is very common to use flame retardants. However, we know that flame retardants, they do not have a good interaction with polymers. This loss of property is potentialized by the amount of flame retardants that must be applied to wires and cables. The compatibilizing agent improves the connection between the two different materials, increasing tensile strength, flexural strength, which is also improved by the use of compatibilizing agents. Thank you. We have one additional question. What is the role of these agents in composites, and what is the proportion of its use? Excellent question. Well, the role is the following. In the composites world, we have the migration or the loss of the wood part precisely because there is not a good interaction with polypropylene. This material, after a while, or after it is exposed to the weather, to sun or to rain, it has a loss in its surface. It's damaged in the surface. and it's hard to compact it as well. So same thing, we gain in tensile strength, flexural strength with the use of these agents. The proportion of use relies on the proportion of use of the wood dust. If you are using 30%, you're going to have to use about 1 to 1.5% of agents. But if you have 50% of wood dust, you can go between 1.5 to 2%. Of course, it depends on the polypropylene that is used, on the residue, on the wood residue that is used. And this allows us to work. The proportions are low, okay? Great, thank you.
Wonderful presentation. Rafael, highly punctual, answered our questions. And I believe that all participants in this event will start thinking about the compatibilizing agents as of now, because they have more information now. Rafael, as he said, he's going to be with us in the afternoon in the Latin American webinar. So thank you so much, Rafael, Brentag. Thank you so much for participating and being here with us. See you in the afternoon, Rafael. Very well. See you then.